So what we're going to do is we're going to go over the different functional groups and their names. Now when we're naming our functional groups in a simple chain, if only one functional group is present, naming the chain is relatively easy. But if I have a more complex organic compound that has more than one functional group on it, then knowing which one has a higher priority is of importance, because that will tell me which one gets named in the suffix and then which ones would get named in the prefix. But whenever we determine the name of a compound, we always have to determine our longest chain, our primary functional group. We have to name our longest chain. We have to name our primary functional group. We have to identify double, triple bonds, name side chains, and assign. So what we'll do is we'll just go through our functional groups from lowest priority to highest priority for the most part. So the lowest priority functional group we've already talked about in class. It's a nitro. It's an NO2 attached to my organic compound. And these are in a lot of explosive organic compounds. And because it's the lowest priority, it's always named in a prefix with the prefix nitro, and we have to state its location. The second lowest functional group, which we've also named, is our acyl halides. And it's where we can have at least one halogen. We already talked about naming this as well in class, where it is named in a prefix, and depending on the halogen, that determines what the prefix would be. And we have to, again, always make sure we state its location. After that, the next lowest priority functional group that we'll talk about are ethers. And ethers consist of two carbon chains joined together by an oxygen. So here we can see we have a two carbon chain attached to an oxygen, as well as a one carbon chain attached to the oxygen. Because this is low priority, it's also named in a prefix, where our longest chain would be our root, and then the shorter chain would be named as a side chain. Except rather than using the ending YL for naming the side chain, we just replace it with the oxy, and we have to make sure we state the location. Next up are amines. Amines are interesting in that we take one of our hydrogens on our chain and we replace it with a derivative of ammonia, where one of the hydrogens on the ammonia is also replaced with the carbon chain. Now, because nitrogen has three hydrogens, that means it could bond up to three carbon chains at once. And so depending on how many acyl groups or carbon chains are bonded to it, that determines our type of amine. It's important to know the type of amine because that will help to determine both its physical and chemical properties, which we'll talk about later. But the naming of them is relatively simple. Just we have to take into account if we have a secondary or tertiary amine. So if my amine is the highest priority, it gets named in the suffix and it gets the amine, and we state the location. If it is not, then it gets named as an amino. Now, if I have a secondary or tertiary amine, my longest acyl chain is my root, and then the other acyl chains are side chains, except because they attach to the nitrogen, then to the main chain, we state their location as being N. So for example here, my longest chain is 5 carbons long, so therefore it's a pent, and that would be my root. And now because it has an amino group attached to it, it's a pentanamine, and I have to state the location. Then I have two other acyl groups attached to the nitrogen, one being a methyl group and the other being an ethyl group. And because they're attached to the nitrogen, their location is stated as N. So then when I put it all together, we still follow our alpha order. Okay, our next highest priority above our amines are our alcohols. An alcohol is has a hydroxy group attached to it. Okay, so if my alcohol is the highest priority, it is named in the suffix with ol, ol. And if it is not the highest priority, then it gets named as a prefix as a hydroxy. just like amines, the carbon that the alcohol is attached to will determine the type of alcohol it is. Or more importantly, the number of carbons that the carbon that the hydroxy group is bonded to. So if the OH group is bonded to a carbon that is bonded to only one other carbon, then it's a primary alcohol. If it's bonded to a carbon that's bonded to two other carbons, then it's a secondary alcohol. And if it's bonded to a carbon that's bonded to three other carbons, it's a tertiary alcohol. Again, this will matter for its physical and chemical properties. After that, we have two functional groups that are very similar in structure. The difference is where it is located. Aldehyde and a ketone consist of a carbonyl group. Now, if the carbonyl group is on a terminal carbon at the end of the chain, then it's an aldehyde. If it's on a carbon in the middle of the chain, it's a ketone. Now, ketones are higher priority than alcohols, but they're lower than aldehydes. So if a ketone is my highest priority, then it gets the suffix ONE, and we have to state the location of it. If it's not the highest priority, then it gets the prefix oxo. My aldehyde, if it's the highest priority, it gets the suffix AL, or al, and if it's not the highest priority, then it gets the prefix formal. And I have to state the location of where it's located, obviously. Now, what we're going to do is we're going to jump to our highest priority functional group, because the last two that we're going to be looking at this year are derivatives of it. So the highest priority functional group is a carboxylic acid. And so because it's a carboxylic acid, can only be on the end carbon, it will only be named in a suffix. We will not be looking at any functional group of higher priority. Okay, so when we name them, we would drop the E and replace it with oic acid. The carbon that has both the carbonyl and hydroxyl on it, which forms my carboxylic acid group, is always carbon 1. Now, one of the two derivatives we'll be looking at of carboxylic acids are esters. An ester is formed from the reaction between an alcohol and a carboxylic acid. And so it looks like it has an ether and a carbonyl in it. But the important thing about them is that knowing what alcohol and what carboxylic acid they were formed from is important for their naming. Now, unlike any others, the root for this is always the acyl group that was my carboxylic acid. And the prefix acyl group is the one that came from the alcohol. My root would get the ending O8. So for example, if I look here, I'm going to put a line through my oxygen. I can see that I have a carbonyl group on the carbon chain to the right of it. And so as a result, that's automatically my root. And since it's 2 carbons long, it's an eth. And I would change single bond, and then I would change the ending to O8. So it's an ethanoate. The other side, even though it's a longer chain, because it doesn't have the carbonyl group, I know it came from the alcohol. So it's named in a prefix, and it's a butyl. Now, when I put their names together, it's a butyl ethanoate. This is the only time that we ever have a space between my prefix and my root. The last functional group that we're going to be looking at, which is higher than aldehydes but lower than esters, are amides. And amides are also formed from a reaction of carboxylic acid, but this time it's a reaction of carboxylic acid with a primary or secondary amine. And we'll look at why at a later date. Okay, again, like we did before, my longest chain is the chain with the carbonyl group, and then the other carbon chains that are potentially attached to the nitrogen are then denoted as side chains, and their location is stated as N. So here I have a 3-carbon root because it has my carbonyl group. Because it's an amide, propanamide, I don't have to state the location because it's assumed to be on carbon number 1. And then I have 2 other acyl groups attached to it, one a 1 carbon and one a 2 carbon. Since they're both attached to the nitrogen, they are Ns, and then I just put the name together. So as a result, when we look, we end up with this overall list of our functional groups, from highest priority at the top with carboxylic acids to our lowest priority nitros at the bottom. So this would be used for doing things for, most importantly, in terms of numbering the chain and also determining which functional groups get named in prefixes and suffixes.